Okay, this video should be pretty short because this is probably something that you've seen before, but you haven't really necessarily thought about it as a conversion factor. So that's going to be the new intro thing to here. This is basically going to be how can we talk about, now that we know what a mole is and how many atoms and molecules are inside of one mole, can we now talk about the mass of something that actually is feasible to us, like we can actually weigh out grams, and use this thing called molar mass as a new conversion factor, okay? Now, the mass of a mole of an element is just basically the mass that you pull off of the periodic table, and we're going to say that's how many grams per 1 mole of that substance there is going to be. Okay, so for instance, if I look at this periodic table, and if I look at carbon, okay, this number right here is the AMU, meaning it's the average mass unit, which deals with how many, the percent abundance of the different types of isotopes for carbon. Okay, so that is 12.01 AMU. Now, I can now take that 12.01 and turn it into a conversion factor, so I can convert from moles of something, which means something to me in chemistry, to grams of something, which I can actually weigh in the lab, okay? So that conversion is going to be 12.01 grams per every 1 mole of carbon, okay? And that's going to be how I develop a conversion factor from moles of a substance to grams of a substance, okay? So this is defined by the periodic table, okay? I can do the same thing for silicone. Silicone's AMU is 28.09, so I can write 28.09, and I can say that its molar mass is 28.09 grams per mole, because every time you have per something, it's 1, right? Just like miles per hour. So if you're going 65 miles per hour, that means you travel 65 miles in 1 hour, okay? Same thing for copper. Let's do copper. So I can say copper's AMU is 63.55. So I can turn that AMU into a conversion factor and say 63.55 grams per mole, right? And then I can use that conversion factor to either go into grams or go into moles, okay? Let's do one more lone element. Tin. Tin is 118.71. So 118.71, which means its molar mass is going to be 118.71 grams per mole. Okay, now what if I have something that's more than 1 element? I know that this is in the element section, but we can kind of move these guys down here, and I'll talk about that. If I'm given a compound, so more than 1 element is present, all I'm doing is adding their masses together, right? So for instance, for water, hydrogen's AMU is 1.01, oxygen's AMU is 16.00, so the total is 18, well, there's 2 of these, I'm sorry. So it's going to be 2 times 1.01 because there's 2 hydrogens. So it's going to be 2.02 plus 16, which is 18.02 AMU, which means water's molar mass is 18.02 grams per mole. Okay? Okay, and I can do the same thing for this complex, which is just sugar, or sucrose. So I can do carbon, there's 12 of them, right? Carbon weighs 12.01, so I'm going to do 12 times 12.01 plus 22 hydrogens times 1.01 plus 11 oxygens times the 16. So if I do that in my calculator, 12 times 12.01 plus 11 times 16, I'll get an molar mass of this guy to be 342.34 grams per mole. Okay? All right, let's do a couple more, and then the rest will be checked for to make sure that for completion, to make sure that you watch this video. So if I'm determining the molar mass of carbon monoxide, I would do carbon's 12.01 plus oxygen's 16 and you should get 28.02 grams per mole. Carbon dioxide, it's the same thing. I'm going to do 12.01 plus, this time I have 2 oxygens, which this is going to be 44.01 grams per mole. Okay, go ahead and try sodium, and then I'm going to do these two, or one of these on the back, and then I'm going to make you do the other one. So let's look at E. I want you to try D after I talk about E. Okay, so E, there's 2 aluminums, okay, so I'm going to do 2 aluminums, which is 2 times 26.98 plus, okay, now this is just like in math class. When you have a number outside of the parentheses, you're going to distribute that number, okay? So 3 is going to go to sulfur and to oxygen. So this means that I have 3 sulfurs and I have 12 oxygens. Okay, so if I do all this math, so I'm going to do 2 times 26.98 plus 3 times 32.07 plus 12 times 16, I'm going to get 342.17 grams per mole. Okay, and that's how you calculate molar mass. Molar mass is just how much does it weigh on the periodic table, and then we add them all together, especially if I have a compound.